Hello everyone, so now let's do one more lab. Now we are going to do the GRE lab. GRE is one of the VPN type, okay, one of the VPN type, but it is not secure. Anyhow, we are going to learn what is GRE and how we can configure the GRE. So if you see, let me give you some overview about this topology. If you see, this is our head office, okay. Let me draw here. We will have our head office and we will have our branch office, okay. If you see, this is our head office and this is our branch office, okay. How we can make the connectivity? Imagine this is your company employee, maybe this is the IT guy, HR guy, or you are working in the head office. You want to communicate with the branch office PC or any server or any resources. You want to access any resources from your head office to branch office to head office. How we will do? Imagine this is a, what we can say, this is a Hyderabad, okay, and this is a Delhi, okay. And how you can connect from Hyderabad to Delhi? It is very difficult, very long distance. You cannot run your own cable, right? So we will use the ISP. So whenever you are connecting from Hyderabad head office to Delhi branch office, how you will connect? You will connect with the help of ISP. ISP is nothing but internet service provider. ISP is nothing but internet service provider. So you have two options. You can use the virtual lease line, okay, virtual lease line, that is a private line. So this line for your data only, you can send your data directly, okay. You will have the ISP cloud, you can send your data directly. That is a virtual lease line. But this will be expensive. If your company is not having that much budget, then you cannot afford this one. Virtual lease line, that is MPLS. You cannot use that one. So another solution is what we can do. We can configure the VPN. So GRE is nothing but one of the VPN type only, but it is not secure. Later we will see we can configure GRE and we can put the IPsec to make them secure. Okay, so GRE. So what we can do, we can make the tunnel from here to here. We can make logical tunnel like this way from GRE. GRE stands for generic routing encapsulation. GRE stands for generic routing encapsulation. What we can say, GRE is a tunneling protocol developed by CISCO. Okay, developed by CISCO. So this is the CISCO proprietary and it will work in the CISCO device, GRE. Okay, and what we can say here, if you want to make communication of your LAN network of the head office to the LAN network of the branch office, you can use the VPN. You can configure the VPN. We have different types of VPN. We have IPsec VPN, but now we will look for GRE. So GRE we will use. We will configure the GRE so our LAN network from here to here they can communicate. Okay. And one more thing, what I can say, example, if you see here, what we will do, we will make logical tunnel from this router to this router. Like this logical tunnel we will make. So our LAN network is going to communicate head office LAN network with the head office branch LAN network. If you want, before it will not communicate. Let me explain you. See here, this is the internet service provider. They give you the internet connection. You connect the cable here and they give you the public IP. You assign the public IP to this router. Same thing you will do in the branch office also. In the branch office also, ISP give you the connection. You will connect here and they will give you one public IP. You will assign the public IP. They told you put the default route towards the ISP router. So this is ISP router IP. You will put the default route towards this ISP. Same thing you will do here also. You will put the default route towards the ISP. Okay, so this is a public IP. ISP give you for the head office and they ask you to put the default route. Default means any traffic, whatever is coming, if you don't have that route, you will forward that traffic towards the ISP. So you will forward all the traffic to the ISP here. Same thing here also, we will forward to the ISP. in this scenario, in this lab, we are taking only one router as a ISP, but in real scenario, you will have many routers. Maybe you will have 100 router, 200 router, lot of routers. Okay, but for lab purpose, I am using only one router. What we will do in the enterprise network, in our company, what we will do? We will just assign the IP, whatever public IP given by the ISP, and just put the default route towards the ISP. Same thing here also, we will do that one. Put the default route and assign the public IP. After that, you can communicate to the internet. You can access Google, YouTube, Facebook, whatever you want. You can access here also, and here also you can access the YouTube, Facebook, Google. But the problem, this LAN network will not communicate with this LAN network. To make the communication between this LAN network to this LAN network, we need to configure the GRE, that is generic routing encapsulation. In GRE, we are putting packet inside the packet and forwarding that one. Okay, so let's do that one. Let me explain IP schema. This is the public IP. This is the public IP ISP give you. And this is a ISP router. It is having this IP, this side, this interface, this IP in this interface. And this is a public IP ISP give you. We assign here. This is the public IP ISP give us. We assign here. And this is our LAN network IP. We taken this is a private IP. We use here the 1.1, 192.168, 1.1 in the head office LAN side. And we are using the public IP, private IP 192.168, 2.1 in our LAN side of the branch office. Okay, so now we need to configure the GRE to make the communication between our LAN network. So what we need to do to configure the GRE, we have the step. First step, we should have the public IP. So we have here. Second thing, we need to have this IP, public IP reachable to each other. So public IP will be reachable to each other because we are taking from the ISP that is having the internet connection. So they are reachable to each other. Okay, so after that, what we need to do? We have some step we need to follow that one. So first step, we will configure this IP here and we will configure this IP here. We will this work will do by the ISP. We will configure IP here, this one, and we will configure this IP, this interface. We will forward the default route here. We will forward the default route here. After that, we will have the GRE configuration. I already wrote here. Let me show you. Okay. If you see from here to here, this configuration, from here to here, this configuration is for the ISP only. Okay, we will not do in the real scenario, but for the lab purpose, I done here. What I done? I write the name as a ISP here in this router. I assign the IP here, this one, and this IP here. That's all. This is only the configuration for the ISP in our lab. In real scenario, we will not touch the ISP router. ISP, internet service provider responsible, they will do themselves. We will not touch the internet service provider router. ISP is like a Tata or Airtel, Vodafone, BSNL, they all are the ISP. So we will not do that one. Our configuration for the head office. So what we will do here in the head office and the branch office. If you see, this is our head office. What I done? I go in the enable config T, I change the host name. I assign this IP to the interface of the router, this one. Okay, and also I assign the IP to this other interface also, this one, this IP, this one, and I put one default route towards the ISP here, this one. Okay, same thing we need to do here also. So let me show you. I done that also here. Let me show you for that also. If you see, this is a branch office also. In this one also I done same thing, enable config T, branch 1, I assign the IP. Here also I assign the IP. I put the default route towards the ISP. This is the ISP IP I put. So this is the basic configuration we done. After that we will do the tunnel. So before copy pasting this configuration, let me show you. Tunnel I am going to explain you. This one I am going to explain you. Before going to that one, let's check here what we have here. What configuration is available here. So what I will do, I will write here show run. Okay, I will write enable config T, or let me write show run. So we will check. I will write show run. Okay, before I configure here, so that's why maybe I have the configuration. So I will check. Okay, I have the tunnel here already. I configure here before. Okay, so if you want, I can remove and I can do again. Okay, or I can explain the configuration and we can paste the configuration. Your wish. What shall I do? or if you want I can change the router, I can put the other router also. Example, what I mean, instead of removing the configuration, I will put this router here like this way. I will put this router here this way. Here I will write head office, headquarter 1 I will write, because same name I have here. And this is the BR1 I wrote, so I will write BR, only BR I will write, branch office. I will remove this cable from here, I will put here. Okay, because I don't want to remove the configuration by writing no, that's why I am doing this way. Like this, I connect to this interface. Same thing here, this way I will connect the fast Ethernet 0/0, and here will be fast Ethernet 0/1. Okay, and now we can remove this router. This router is already having the configuration pre-configure. Now I want to show you from starting, that's why I removed that router. So now this router is not having any configuration, this is like a empty. Now we are going to do the configuration from the starting, from the basic. If you see, this is a brand new router, it is asking me to put the name here. So what I will do here, this is a basic configuration. If you see, from here to here, this is a basic, just assigning the IP address and putting the default route. I will paste this configuration there. Okay, so first I will write no here, and then I will paste this configuration. When I paste the configuration, no error, nothing, everything is good, working perfectly. Okay, everything is good, working perfectly. Now I will copy this one I am going to explain you after some time, so don't worry for this one. Okay, so now I will use the basic configuration from here to here. I will copy and I will paste this also in the router. Okay, here. Now let me paste in the branch office also, everything is good here. So now branch office is okay, just we done the basic configuration. Now example, if you want to test, from here I already assigned the IP. If you want to check, see here, this PC is having 192.168.1.2, and this is a default subnet mask, and default gateway is this router IP interface. Okay, now what I will do, example, I want to ping here, I will write here ping, and this LAN network I want to ping continuously, this one. Which LAN network? This one, 2.2. So I will write -t and then 192.168.2.2. Okay, now we will have destination host unreachable, and the request timeout we will have because we don't have the connectivity between the two LAN network. Okay, so this will work here, and I will show you this. Let me show you this also. Here we have the IP 2.2 default subnet mask, and this is a gateway. Gateway IP is here. This is a gateway IP 192.168.2.1. We have everything is good, but even though we are getting the destination request timeout here. Okay, and if you see here, we have the connectivity here. Let me ping ISP IP 200.1.1.2. So I can ping to ISP. This is my ISP IP. Okay, and if you want other site also, let me show you this one. The other side I am pinging, it is also working. So this is a two public IP. This is my public IP, this is another public IP. They are reachable to each other. Okay, they are reachable to each other. So this is the first condition in the GRE. Public IP should reachable to each other. Now we need to configure. We did not configure the GRE. Only we configure here default route, it is going here, and this is a default route going here. But our LAN network cannot communicate because this is a private IP, this is a public IP, and now we need to make the communication between two private IP. So what we are going to do, we are going to run the virtual tunnel between these two routers. It will be like a virtual tunnel, like directly these two routers are connected to each other. Like that we will do virtually. Okay, if you have the virtual lease LAN, we can do that is very easily, but now we don't have virtual lease LAN, we have only internet connection. So with the internet connection we need to do. Some company they are using this technique also because they don't have budget to buy the MPLS link. Okay, to take the MPLS link they can use this one because it is charging less. Only you need the internet connection with the public IP, static public IP. Okay, so what we need to do, we need to put one IP here. Okay, for our tunnel we need to create the tunnel. We are saying we will going to create the logical tunnel from here to here. So when we are creating the tunnel we need to give some IP. So I taken this IP. Okay, this IP should be in the same subnet, so they can communicate. So you can take anything. I taken this one, private IP. You can take any private IP. I taken 172.16.1.1/24. Here I am taking 172.16.1.2/24. Both are in the same network. So I am going to create the logical tunnel like this. This is a logical tunnel between this router, and this side of the tunnel I am going to assign this IP, and this side of the tunnel I am going to assign this IP. Okay, so what we are going to write? We are going to write interface and then tunnel, and give the tunnel number example 1, and then assign the IP. So this is a configuration for that one. So let me show you. So see here this one, if you see, this is a interface tunnel 1. We can give any name here, any number. I am writing 1 because I am using tunnel 1. So you can use 2, 3 if you want to create more also. No issue. So I am writing here tunnel 1, interface tunnel 1. So now tunnel 1 is created. Then we need to assign the IP. So how we will assign the IP? We will write IP address and then write the whatever IP we plan. So we plan 172.16.1.1 and /24 is nothing but 255.255.255.0. After that, what we need to do? We need to define the tunnel source and tunnel destination. So we will write tunnel, this one, tunnel source, because inside this one we are doing this one, this all configuration we are doing inside the tunnel 1. So we need to write tunnel source. We need to write tunnel source. Who is the source? This is the source starting from here, F0/0. And tunnel destination, where this tunnel should finish, this side. So we will write this IP. So tunnel destination is, what is the destination? This side. Public IP we need to write, not the private IP. See here, I am saying tunnel starting point, finishing point. So tunnel starting points, starting public IP we can write, but some router is not supporting, so we need to write the interface. And we need to write destination tunnel IP, destination IP we need to write. So destination is here. So this public IP we need to write. So we will write tunnel source here, public IP, but some router is not supporting. If it is not supporting, then we need to write the interface. So this interface is fast Ethernet 0/0. And then we will write tunnel destination. And this is a public IP. Here till here we need to find the tunnel. So we will write here tunnel, and the destination is this public IP, whatever ISP give. Okay, this way we will create the tunnel. Same thing we will do. This head office we finish, branch office also we will do same thing. Here also, if you see, what we will do, we will write interface tunnel 1, and we will assign the IP here also, whatever IP we want to assign. Example, here we use, what IP we use here, 172.16.1.1. So here should be 16.1.2. Okay, because we are using here what, 1.2. So this tunnel will have 172.16.1.2, and this is a subnet mask. And tunnel source means this public IP. If router is not taking that one, then we will assign this interface. So this is the interface, and then tunnel destination, and tunnel destination is this destination public IP. So we will write this public IP. With this one, tunnel will be created, but we need to run some protocol to exchange this route. Okay, so what we can do? We can do the static route, or we can do the dynamic route. We can run the OSPF, EIGRP, ISIS, whatever we want, we can do. So here I am doing the EIGRP. So we can write router EIGRP1, no auto summary, and which network we want to advertise. We want to advertise this one. So I will write 192.168. This is our head office, right? So in head office, what I will write, 192.168.1.0. Okay, this network we need to advertise, 192.168.1.0, and this one 172.16.1.0. This one and this one we need to advertise. And here also same thing. Here we need to advertise this our LAN network. If you see 192.168.2.1, so this is a 192.168.2.1, and here this will be 172.16.1.0. Okay, network ID we need to write. So 2.0 here, because this is a 2.1, /24 this one, and this one also /24. So we will write 192.168.2.0 and 172.16.1.0. Here what we wrote, 192.168.1.0, and this one 172.16.1.0. That's all. Okay, we will write this way. So now what I will do, I will take this configuration. This is for the head office. I will paste this in the head office router. I will go in the head office. Let me go in the global configuration mode. Okay, now I am in the global configuration mode, and if you see, tunnel is up, it is created successfully. If you want to check, you can write do show IP interface brief. If you write here, you can see this is a tunnel 1 and this is the IP of the tunnel and it is up. Okay, now let me do this configuration. Let me do this one. I will paste this in the branch office. Okay, so I will go here. This is a branch office. I will paste this here also. Here also tunnel created. If you want to check, do show IP interface brief. So you can see this is a tunnel 1 and it is up. Okay, now this one is good, perfect. After that, we need to run the EIGRP. Why we need to run the EIGRP? So they can have the root. You can run the EIGRP, OSPF, ISIS or static root you can do. If you see, still here they will not work because still they don't have the root here. Okay, request timeout, still request timeout. Continuously this guy, the head office guy, is pinging to the branch office, request timeout. Now we need to run the any routing protocol. So now what I will do, I will run this EIGRP. Okay, what we are saying, router EIGRP1, no auto summary, network and the network ID and the network ID. This is the network ID, this is the network ID. Okay, if you want to run OSPF, if you want to run what we can say the static root, you can run static root also or OSPF also. Anything whatever you want, you can do that one. Okay, now what I will do, I will copy and I will paste this here. Okay, let me go to the head office and I will paste here. I will paste this here. And what else we can do, same thing, we need to paste this one in the branch 1. Okay, so now let me paste in the branch 1. After some time they will have the neighborship. If you see, this tunnel 1 is up and they have the EIGRP neighborship. Okay, and if you want to check here, you can check, you will have the roots. You write show IP root, you will have the root. If you see, this D is nothing but what we can say, this D is nothing but EIGRP, and if you see 192.168.1.0 root we have in the branch. Okay, if you want, I can write do show IP root EIGRP. If you see, we are learning this root 192.168.1.0, we are learning this one. Okay, so now everything is good. Let me save the configuration, and if you go here and you can check, see, before it is not working, but now reply is coming, right? Before it is not working and now it is working. What we are pinging from 192.168.1.2, we are pinging 192.168.1.2. This guy, that is 1.1, is pinging to 1.2 and this is a 1.2. It is working perfectly, right? Example, imagine you have one server here. Okay, this is one server. Let me give the IP 192.168.1.4. okay, this is just label, I am putting the label. Let me put this IP to the server here and let me give the gateway. This will be the gateway and I will connect here. Okay, this is our server. Imagine example, this guy want to access these services. Okay, so what they will do, they will go here and they will write the IP of this one 192.168.1.4. so they will access. If you see, they can access the web server also. Okay, they can access the web server. If you want the HTTPS also, let me write HTTPS and we will check HTTPS. Let me check first of all it is enabled or not. I will go here, let me go to the services, and in this one, if you see, this one is on, HTTPS also on, HTTP also on, so it is working perfectly, no issue. So if you see, if we see, HTTPS is also working, and if you remove the S also, it is working. Okay, this is our site. What we can say, this is our site. If you want to modify this one, I can modify. Instead of this one, we can edit, and here I can write the name. Example, I will write Networkforyou. Okay, and let me write in the bold, or let me write this one only. Let me save this. Yes, save. Now let's see it will change here or not. Let me stop and let me do again. Let me type 192.168.1.4. okay, 1.4, and I will press. This is the where I modify. Let me check where I modify. This is in the HTML. I save. No, let me save, and I can go here. Did he? No, I think it is not saved here. Here is index. Let me edit here. Okay, here we need to edit. So here I will, what I will do here, let me write here. Let me write here. Okay, here I will write network net for you. Okay, this just to show you. Okay, here I save, and now I think I edit correctly, and now let me refresh. Yeah, see, this Networkforyou came here now. Okay, so now what I am saying, we are accessing this server. How we are accessing? We don't have any what we can say, we don't have any routing protocol between this to this. This is a internet, because in internet router we cannot run. If we are connected this one to the ISP, we cannot run the OSPF or anything in this link. That's why we created the virtual tunnel here, and we run the EAGRP here and here and here and here. Okay, so this way this traffic is going. Instead of one router, instead of this one router, maybe you will have 100 of router here. Okay, but it look like you are directly connected. That is nothing but virtually you are connected. That is known as GRE. Okay, I hope you understand this one. Before closing, let me show you the configuration. If you have any confusion, write in the chat box, write in the comments. We are going to help you also. This way we create the tunnel, we assign the IP to the tunnel, and then define the tunnel source, define the destination of the tunnel. This is a destination IP, and configure the dynamic routing protocol here. Same thing we will do here also. That's all. So this is a GRE lab mini project, generic routing encapsulation. We are sending packet inside the packet. This is a one type of the VPN. Example, if you want to connect the two branches, if you don't have the MPLS link, you want to connect even with the internet link. So you need to have the static public IP, and public IP should be reachable. Then you can configure this one. This is a GRE, is a Cisco proprietary. This will work only in the Cisco device. Okay, but this is unsecure. If anyone capture the packet, they can see the data. To make this secure, what we can do, we can after creating the GRE, we can run the IPsec. Okay, after creating the GRE tunnel, we can put the IPsec. So with this one, we can encrypt the data also. Okay, but why we are using GRE means GRE support the multicast and broadcast traffic. If we configure directly IPsec, IPsec is not going to support the broadcast and multicast traffic. That's why first we need to run the GRE, because GRE is supporting the broadcast and multicast traffic, because our dynamic routing protocol are using the if you remember multicast. If you remember 2264 like this DR we are saying, if you remember, we are using the multicast. So just remember, dynamic routing protocol is using the multicast to update the routes and to send the hello packets, all that one. If we configure the IPsec, then we will have the issue, multicast will not work. So for that purpose, first we will configure the GRE, and after that we will configure the IPsec to secure that one. But now just we are discussing about the GRE. What is GRE? That's all. Okay, thank you, see you, bye.